So in this video, we're going to find the arc length of an arc that is considered a major arc. When we're given a central angle that's pretty small, like this one that's 45 degrees. If you want to find the arc length of a major arc like this, you do it exactly like you would do it with a minor arc, like I did in the other video. If you haven't watched it yet, I would recommend watching it first. But you're still using the circumference of the entire circle and setting up a proportion to find the not the circumference. You're finding the arc length of just the major arc that's around the circle. Okay, so it's a proportion from the entire circumference to just the piece that's around the major arc. Okay, so what we're going to do is find the circumference of the entire circle first, and circumference is pi times diameter. And in this problem it says that angle AOB is 45 degrees, which is here, and the radius of the circle is 3 inches. Now it doesn't give me the diameter directly, but because the radius is 3 inches, I do have the diameter. And since it says the radius is 3 inches, I'm going to label my circle over here. I can either label AO or OB. I'm going to label OA, that it is 3 inches. And because that's 3 inches, I can kind of draw like a little imaginary line over here that represents my diameter. If my radius is 3 inches, then I know this is also 3 inches over here, making my entire diameter double the radius, which is 6 inches. So I can go ahead and say that my circumference is pi times 6, making my circumference 6 pi. And because this is in inches, I'm going to say that it's in inches. I'm not going to put squared because we're not finding area. Now I can go ahead and set up my proportion. I'm going to do the circumference of the entire circle, which is what we just found, 6 pi, over the degrees of the entire circle, which is 360. And I'm going to set that equal to what I want to find is just the arc length around from B to A, the major arc, which is part of the entire circumference. So I'm going to match the circumference here with the part that I want to find, which is going to be my variable, over, and I don't want to find the 360 degrees because that would go all the way around the circle. I just want the part that goes around from B all the way to A, and I don't have that. But I know that all the way around the circle is 360. So if I have 360 degrees all the way around the circle, and the sector that I have on my diagram is 45, I do have the ability to find out what the rest of it is by taking 360 minus 45, and I'm going to go ahead and do that here. 360 minus 45, and that gives me 315, so I'm going to label that on my diagram. So all of this part is 315 degrees around the rest of the circle, and that's going to go down here. Now I can cross multiply and divide to find out what my arc length around from B to A would be. So I'm going to take 6 times 315, which gives me 890. So 360 times x is 360x equals 1,890 pi. And then I can divide by 360. That gives me x equals, divide by 360, I get 5.25 or 5 1/4. To figure out exactly what that is as a fraction, I can hit the math key, which, let me slide this in here, is right here. I can hit math, frac, enter, and this comes out to 21/4. I do that so that I'm not approximating my answer. This is an exact answer. It's 21/4 pi. And I'm going to put this in inches. That's the unit for this. And it's not going to be squared because we're not finding an area. And that represents the distance from B to A around the major arc of that circle. The 6 pi represents the entire circumference, but that just represents part of it. The 21/4 pi represents part. So that's how you find the arc length of a large sector around a circle.